Dear participants, we welcome you to the rescheduled session by Dr. M.M.G. Mutt, Associate Professor, Department of Mechanical Engineering, Basaveshwar Engineering College, Bagalkot. Over to Professor M.M.G. Mutt.
Salim on the Salim voice and Kirakatila stop at Aga. Yeah, Kiasakatil just share the Salim. Okay. Well, good afternoon, dear participants. We are very really sorry for the inconvenience caused in the rescheduling. I'll quickly glance at the portion that I have covered yesterday. The topic for the session was DMAIC. I'll just continue with that. DMAIC is a problem-solving approach that drives Lean Six Sigma. When I say Lean, I'll be more worried about the waste that are being defined by Toyota Production System. The DMAIC has 5 phases: define, measure, analyze, improve, and control. This DMAIC is used for improving existing process. I'm trying to highlight this word existing process because this is important for me whenever I speak about Six Sigma, that too in terms of Lean. DMAIC is based on scientific method. The 7 ways of Lean, like transportation, inventory, motion, waiting, overprocessing, overproduction, and defect. These 7 ways are being identified and introduced by the company Toyota. And the 8th one, the skill sets. It is also called as unused manpower or man skills. 9 ways of manufacturing or Lean, because unused machine is also added by some experts. Lean is defined as a set of management practices to improve process efficiency and effectiveness. Now, the existing process, if I come across, there are 2 words found. One is DMAIC, DMAIC, and the other word is DMADV. Under DMAIC, you can read the process to be existing It means the product is already designed and that design is carried over for manufacturing and the process is in place. The DMAIC process, as I said, it is define, measure, analyze, improve, and control. What could be the other process other than existing? Yes, it is the new process. What do you mean by new process? It is entirely the new process which you are trying to finalize or plan for a product which is at the design stage. That is why DMADV stands for define, measure, analyze. D stands for design and V stands for verify. DMAIC and second is DMADV. DMAIC is for process improvement, whereas DMADV is for product design. We do modify the design at various stages and accordingly we do design the process, and that process is going to be the new process. Well, the words say sorry. Sorry for the disturbance. When I say existing processes falling below specification, this word is important to me. When I say below specification, I think if you remember Dr. Shiva Prasad on the first day, he was repeatedly trying to use the words upper specification limit and lower specification limit. Anything that falls within these two limits is acceptable. Here, any output that you get from the process, if it is acceptable, it is fine. If it is below expected or acceptable, then that is said to be called as below specification. And there you have a room for improvement. And there is another word, looking for incremental improvement. Incremental is a very small change that I can bring upon the process improvement or process change in terms of quality. Whereas in DMADV, an improvement system used to develop new processes or products at 6 Sigma quality levels. Here, already we have established what level of quality I am expecting. And accordingly, I am trying to design my process through the design of the product. You can very clearly understand in this, the last two wordings are design and verify. Both DMAIC and DMADV are inspired by Deming's PDCA cycle, that is plan, do, check, act. In a simple way, if you look at DMAIC, it is to reduce the waste that is happening. Under DMADV, it is to avoid the waste that is going to happen. Well, the first word for DMADV stands for define the design goals. You'll come across DMAIC in the latest slides. There we are defining the process goal, whereas in DMADV we are defining the design goals. Second step, measure. We are trying to measure and identify CTQs, that is critical to quality. It means the characteristics that are critical to quality. And in third step, we are trying to analyze the design and try to develop a good design, a better design. And in the fourth, amongst the good and better, we are trying to finalize the design so that is going to be the best. Once you finalize this design is going to be the best, you are trying to implement and verify the process that it gives the output in terms of quality. In this slide, I have highlighted at 4 places which says that it is QFD. The word QFD stands for Quality Function Deployment. Mr. Arun Kumar, who spoke in the morning, he has helped me a lot by going deep of this QFD. But in a simple way, I'll just glance at the first steps. In the first step, I'm trying to talk about planning of product. In the second step, I'm trying to talk the design aspects. In the third step, I'm trying to talk about the process considerations. And in the last step, I decide upon the plan for manufacturing the designed product in the third step. I think it will be easier if I go in the other way. In the first step, the voice of customer are translated into technical dimensions. Voice of customer is nothing but what customer wants. In the second step, technical dimensions are translated into part characteristics. In the third step, part characteristics are translated into manufacturing operations. In the fourth step, manufacturing operations are translated into product features. Single word I would like to define here. From voice of customer, I have now come to product features. Whatever customer has demanded, I have put forth all those demands in terms of product features. Some people would be asking me the question, sir, should we start with DMAIC and go to DMADV, or DMADV to begin with and move towards DMAIC, or whether both are interdependent or dependent between the two? Now, the first 3 words, you are trying to find that they are common. But I do differentiate very clearly. Any define the stage at DMAIC, you talk about process. The define that you talk under DMADV, you talk about the design. You are defining the problem related to design under DMADV. Whereas you are trying to define the problem related to process under DMAIC. Similarly, you are trying to measure the process performance, current process performance under DMAIC. Whereas under DMADV, you are trying to measure the design specifications. Similarly, you analyze the current performance of the process under DMAIC, and under DMADV, you are trying to analyze the design specifications. And as it goes with 4th step of improvement, the process improvement plan that you have done in analysis under DMAIC is implemented and improvement is expected. Whereas in design, we are trying to modify the design, analyze the design in the upper stages, and that is going to be implemented in the new process form, and then validate whatever the design that you have finalized with a new process. Yesterday, when Mr. Ashok was speaking, there was some difficulty in differentiating. This purely talks about design. Here, we do talk the design activities up to 90% and 10% about process. Whereas under DMADV, we do talk about the design and process hand to hand or parallelly. Here, some people accept that DMADV and DFSs are same, one and the same, and some people they feel that they are different. It is to be awaited. There is a word called re-engineering. It is because we design the product first, and based on the requirement of the design, we as I said, some people process under Six Sigma. But before I get into DMAIC, I have to select a project. The focus of any process improvement effort is in selecting the right project. What do you mean by right project? The project that really is a gain is said to be called as good project. Once you select a good project, you have to select good candidates. What do you mean by good candidates? Candidates are those who have a little knowledge, a better knowledge of Six Sigma in terms of green belt, black belt, and champion level. What are these green belt and black belt? I think already some part is covered. I'll just glance at the wordings. The white belt is the initial where I do not know anything or I'm not at all educated. Yellow belt, it is for those who are non-technical. Green belt, it is the quality importance thrown at technical level. Black belt are those who almost become familiar with the QC tools, quality control tools or quality improvement tools. And master belt, they are pioneers in using these tools. Champion, may sometimes we call him as the process owner who decides about the decision that have to be taken about the process. The guidelines for selecting a project: choose an obvious problem within an existing process. When I say obvious, the process should be able to yield the gain. I repeat that word again. Some yield from the process should be in the improvement side. Second, choose something that would make a difference but would not be overly complex. Means the problem defined or the chosen should be meaningful but manageable. Make sure there is a potential to reduce lead time or defects while resulting in cost savings. Potentiality for reduction of things like the waste, rework, scrap, etc. or improving the cost savings or productivity. Next, check if you can collect the data about the selected process. The data should be measurable for improvement. Once you have selected a good project, you and your team can apply DMAIC to dig into the process issues. Here, I'm trying to highlight again the existing process because we are talking of DMAIC. And here, I say we are trying to dig into process. What do you mean by dig? It is going deep into the process till we find a good solution. A good project we come up with. The project selection is choosing a process improvement opportunity. Means rightly we are in the direction to gain the improvement with the greatest impact and most manageable effort. It means we have a method, we have a path, we have a route to move upon towards the goal that we have chosen in terms of the problem. And that problem lies in line with the strategy of the organization. Now, we get into the deeper sense of the process of DMAIC. Lean Six Sigma already we have understood, and DMAIC we are trying to move upon. And here at the upper corner, you find the word only. It means we are restricting only to DMAIC, and I'll not get confused with DMADV or DFSS. Well, under the define stage, I said you have to define the opportunity or the problem for process improvement. Yes, already I have done that. But I have to keep it in mind, the problem that I have chosen as a project, it should be in line with the business and the customer perspective. What do you mean by business? Here, in a single word, I can say, I should have some gain in terms of profit. And customer perspective, ultimately, the customer should be happy, he should be satisfied. Under measure, I should understand the process and its performance at the present level. In analyze, I am trying to search for key factors. What are the key factors? Which are critical for the process or critical to the quality. Those criticality which affect the quality in the process. Under improve, I have to find the solutions for the improvement. But here, I have to consider those criticality which I have observed in the upper stage, and for that, I have to find the solution. And the last step, in the control, I have to maintain the same level of gain that I have gained in the improve stage. This is a roadmap for DMAIC. It says, problem can be solved with 30 steps. Don't be afraid. It depends on the variety of project that you have chosen. But in a common way, we'll go ahead to understand what are the steps to be followed for DMAIC. Define. Here, we are going to introduce 3 words: project charter, voice of the customer, and SIPOC. A project charter lists the main goals of a project and a detailed plan to attain these goals. The detailed plan involves identifying the relevant stakeholders and determining the roles and responsibilities of each individual involved with the project. A project charter is beneficial because it can be created for an existing or future project, making it a useful project management tool. A project charter is an effective presentation tool for upper level management, organizational clients, or potential investors, and can also be used as an accountability mechanism that ensures each member of the project team is doing their job and has a shared understanding of the project. The elements essential for a good project charter: identify the project, mention the dates for start and end of the project, people who are involved in a project, outline the objectives set as targets, reasons for a project charter to be carried out, and this has to be in line with the business, as I said earlier. The detailed description of a problem or an opportunity, the return expected from the project, results that could be expected in terms of performance, the expected date that the objectives are to be achieved, clearly define the roles and responsibilities of the project team members, resources that will be needed for the objectives to be achieved, barriers and the risks that are involved with the project. And the last is effective communication plan. Now, voices. There are 4 types of voices: voice of business, voice of customer, voice of employee, voice of process. Voice of business, what exactly business wants. Voice of customer, what customer wants. Voice of employee, what employee wants. And similarly, what process wants. Voice of customer, the customer judges and buys the product. Hence, the voice of customer is, VOC is customer driven. Voice of business, the business has its own needs which must be met to stay in the business. The voice of business is profit driven. Voice of employee, it is important to meet the employees' needs so that they will stay with the company. The voice of employee is process driven. With all this, employee, customer, and business voices, my problem is the optimization of all these 3. The third word, critical to quality, CTQ. CTQ is a Six Sigma tool used to identify the needs of the customer and translate the information into measurable product and process requirements. It allows organizations to understand the characteristics of a product or service. The most important term that I have to understand in CTQ is what exactly customer needs, or for what terminology he'll be happy. For that, you have to have these 3 words clearly understood: need, drivers, requirements. For that, I'll have this example. Need is customer wants a cup of coffee. What are the drivers? Taste of the coffee, temperature of the coffee, and ultimately the cost of the coffee. Customer says that coffee is good when the cost is low. The customer would also say the coffee is good when the coffee is hot as per his requirement. If it is too hot, he scolds, he blames. If it is less hot, also he blames. He is not happy. And importantly, the coffee should taste. How do you define this driver? Well, I'll try to define in these 2 terminologies. One is, it should not be acidic. Acidic is again in terms of the quantity of milk that is being used in preparing the coffee. Or the other way, the coffee or the taste of the coffee should be rich. Again, it is the combination of sugar, coffee powder, and the milk. The CTQs are the right extreme wordings: acidic, rich, 60 degrees, 80 degrees, and the price for the coffee. These words are going to be critical for the manufacturer. So he has to be worried about these wordings. I'll take another example. Whenever a serviceman is being called, he should have good knowledge, and that knowledge is covered under driver. The other driver is that the serviceman should be friendly. You might have observed many a times that in your lifetime, any representative who has come for the service to your doorstep, he'll be with very rigid face and he'll not be able to speak much to those questions which you ask. He is not interested to speak much upon. You don't like that representative. So the driver is, from the customer end, should be friendly. And the last is on time, timeliness. Whenever customer calls, he should attend the calls, he should receive the calls, and he should attend the problem. On the right extremes, under CTQ, any question you ask, whenever he is trying to repair your product, you'll be asking him, what has happened? Is it because of this? And there he'll be trying to interact with his answers. If he is answering with a smiling face, you like that serviceman or representative. And there, answering correctly based on the knowledge with a smiling face becomes a CTQ. Similarly, the information that the representative has. Maybe that you have taken the latest model of the TV, and the representative, if he is not familiar with a new model, and that becomes the critical or criticality of the quality. I'll just move on. Three things to be. I have satisfaction level here. You have dissatisfaction at this level, downer side. Left hand side, you have the absence of the satisfaction. You have fulfillment on the other side. I said absent of satisfaction. Why customer will not be happy? Because they are not fulfilled. So my job is to fulfill what customer needs so that he'll be happy, he'll be satisfied. For every product, there are some characters which are not to be told, but they are to be there, and they are the must. Example, you have a car, and car has to drive with good mileage. Company has already claimed that vehicle can give you the mileage of 20 kilometers per liter. But customer has a little above the want. If anything about 20 kilometers, he is happy. Suppose if it starts giving 24, he is excited. With this, I'll go one step ahead where the musts are unspoken. They are to be given by the manufacturer. Wants are one-dimensional, which are to be spoken by the customer. And the exciters are the delighters, which customer doesn't know, but manufacturers struggle to give it to the customer. Now, we have understood what voice of customer is, voice of business is, and we have also touched upon the focus areas, that is time, cost, and growth in terms of quality, and we'll try to know what the project charter through SIPOC. What this SIPOC is? SIPOC is a method to properly describe the transformation process within a company that offers products or services. SIPOC is a tool for process improvement that summarizes the input and output of the process. The SIPOC stands for suppliers, inputs, process, outputs, and customers. If you see here, for any process, there are some inputs needed. These inputs are converted into outputs. The same output, if I see here, that could be measured in terms of customer satisfaction through a product or a service. If the product is defective, customer is not satisfied. So what I have to do? I'll have to come back to the process so that I should check why this defect has happened. This is not sufficient that I'll have to only check the process. Now I'll have to come back to the input. What input has gone wrong so that this defect is manufactured? This output is treated as Y. Already you have come across this formula. Y is function of X. X are the variables in the process. And these variables are to be checked in terms of the inputs. Now another two terminologies like supplier and customer are added to this SIPOC, because SIPOC is a high-level view of process. I'll have to view each and everything that is being connected to the process. I'm very familiar with the input and output, but where this output really goes? The output goes into the hands of the customer. So what exactly the customer is looking for? So I have to be very much in care with the last step of customer. And similarly, where do I get the inputs from? The inputs are supplied by the supplier. So I'll have to be more keen on the supplier because he is the real input. SIPOC is a diagram to process the map or mapping the process. Here, I'm trying to develop a network between all the activities under the process. Process, it is a simple, effective method for ensuring every project team member. It also offers an overview of a project at a glance. SIPOC diagram quickly explain a project and provide common reference to team members. It also can help identify the problem and isolate areas that are not needed and add little value. Importantly, SIPOC diagrams are helping team members agree upon a common language and understanding a process for continuous improvement. Measure. I come across new terminologies here again. The data. I have two types of basic data categorized. One is numerical, other is categorical. The numerical in terms of numbers like age, weight, number of children, etc. Categorical, eye color, gender, blood type are the examples. Further, if I move upon, the numerical data is categorized into continuous data and discrete data. Example, age, weight, blood pressure, etc. This depends on the options which are infinite. But based on the finite options, I have shoe size, number of children, where I have restriction. On the other way, categorical data is divided into two categories, ordinal data and nominal data. Ordinal data is hierarchy, is having no hierarchy. Example, eye color, dog breed, etc. for nominal. And for ordinal, it is pain severity, the satisfaction level or rating, and the mood. The strength of the information retrieved by the data is high on the quantitative data compared to qualitative data. That is, nominal data and ordinal data are weak enough, whereas continuous data and discrete data are strong enough. Now, we know the inputs, SIPOC, process map, etc. Cause and effect diagram is already covered in a morning session. FMEA is also covered in a morning session by Mr. Arun. Having known this, now I'll move upon to the data collection plan, where the collected data has to be presented in a graphical way so that I can analyze. You have many tools to analyze the data. I'll take the check sheet as a simple example, where cost for late shipments. The reasons would be material shortage, quality issue, staffing, order entry error, etc. If I use a tally table against the reasons, I can easily find whatever the greater number I find, that is the reason for root cause. In a single way of the word to say upon the FMEA, it is failure mode and effect analysis, where I'm trying to understand where the error can happen or occur with the potential causes and effects. This is done using the RPN, risk priority number, and this is the product of severity, occurrence, and detection. Once I know the RPN, now it is my duty to reduce the RPN. Nothing but indirectly I'm trying to reduce either the severity or the occurrence or the detection, where I'll be trying to reduce the effect of the cause. When I'll be able to use the FMEA? I think I'll just move upon. The data collection plan is a roadmap detailing how to collect and reach each piece of desired data. I say desired data. For that, I have a simple table. The first column, the number, the last column and the first number. The stratification factor. It is what exactly I'm looking for. Example, the crack that is happening in the casting. If I'm trying to measure about the crack, I'll have to come on to the second column, which is operational definition. I'll have to define the crack definition. After having defined, now I'll have to understand the source where I can get this data and the location where I can get this data. Having known the source and location, now I'll have to understand how this data to be collected. It is easy to say how it should be collected, the way in which I have to follow. But in shop floor, sometimes you may find difficulties. After knowing this, who should collect? Is it the manager, the supervisor, or the first line people? When he should collect the data? Is it during manufacturing, online? Is it after the product gets manufactured, offline? And next, what is the sample size? How much data I should collect? The same thing I'll put in this way. Who should collect the data? What data to be collected? When it should be collected? Why it should be collected? And how it should be collected? In this regard, if you can prepare a format, a table, that becomes an easy job. Here, I say what. When I say what, it may be regarding complaints, defects, etc. When I say when, it can be the first shift, first day, third day, or the first month, or monthly basis, daily basis, shift basis, etc. If the question is where, the region, is it on the shop floor? Is it in the QC department? Is it in the materials department, etc. Even sometimes it differentiates, is it in my area or customer's area? Who should collect? Is it the individual, the department, etc.? Determine how the current process is performing. The project team has to establish the current state of the process before considering the changes, because the baseline becomes the standard against which the team assesses the impact of their solution. This is the key step, since the team must eventually compare the data collected during the measure phase against the data collected during the improve phase, so that I can confirm that there is an actual improvement. Create a data plan to collect the data, which already I have explained. After doing that, you have to ensure that the data collected is reliable. Now we'll move on to analyze. By this time, we have the data at our hand. The data that we have at our hand should be displayed using different graphical tools, because selecting the right chart, the right graphs provides the team with valuable insights, the causes of the process issues. Importantly, the statement, a hypothesis statement, is an educated guess about the suspected cause. I repeat, educated guess. Here, I have the data. I have put that data in the graphical form. When I see the graphs, I should be able to draw some guessings, and that should be the educated guess. It means the guessing should be in the right direction. If the guessing is in the right direction, the cause would be in the right one that you are suspecting or trying to suspect. These are different graphical tools like histogram, Pareto chart, RAN chart, which are already covered. So I'll move on to the next slide. Cause and effect diagram is also covered, but I'll just glance how this tool is used. Perform the cause and effect analysis using cause and effect diagram. Determine the major categories. Tackle one category at a time, or select the important aspects from each category and make a separate group and try to analyze that group to verify the root causes in the present performance. And now we'll move on to the improve phase. In the improve phase, we are trying to implement those analyses that we have done and try to see what improvements we are trying to get. The team understands what is the causing element for the problem and how to solve the problem. Once the project team has gone through the data and studied the process to verify the root causes, it is a time to develop the solutions. The improve phase is where the team gets to solve the problem and develop the solutions. The developed solutions can be tried for the pilot batches and implement the solutions to check whether there is a difference between the earlier and after implementation. Here, for improvement, you have to gather the best ideas to fix the problem and select or try to select the practical solution, because here you have different variations, maybe from measurement system or maybe from actual variation itself. Measurement system variation should be from the operator, or variation maybe from the gauge itself, the instrument used for measurement. In actual, the variation may be under controllable situation or uncontrollable situation. Hence, should be tested and refined so that my solution would be the best. Now, implement the solution that you have finalized amongst the alternatives. Require careful planning. The team has to consider logistics, training, documentation, change management, and communication plans. Measure to validate the improvement. Once the team has implemented the changes to the process, they can collect the data to check whether or not the improvement is there in the baseline or not. Or this can take anywhere from 1 week to 4 months, depending upon the length of the process cycle. Why I am mentioning this period is, you have some problems that you have chosen wherein you are helpless to wait for 3 to 4 months to get the results. Now, the control step. Under control, whatever the improvements that you have got in the previous step, you have to standardize. You have to document the methods that you have used to obtain the improvement. You have to monitor the plans that you have implemented so that the improvement is seen and improvement remains. And importantly, the response plan or feedback plan. In the control phase, the team develops a monitoring plan to keep an eye on the continued success of the updated process. Any improvement the project team has done, they hand it over to the manufacturing team further, and it should be seen that the manufacturing team will get the same improvement every time further. And once this handover of improvement from the project team to the manufacturing team, there should be a celebration and there should be a recognition. Because everybody has seen what before it was and what after it is. Any achievement that is seen through Six Sigma implementation, that has to be distributed amongst all the employees of the manufacturing unit. With this, I'll move upon to a small case study which was done at our department. The title of the project was Application of Six Sigma to Improve Passing Percentage in Basic Thermodynamics. Defined phase, project charter. This is the project charter where we have defined the project title. The background, the pass percentage of students is seen around 89%, having minimum as low as 85%. Hence, this study was taken up to improve the pass percentage. the above sentence, if we observe, it is around 89%, means it is 88 point odd. Hence, it is considered to be 88%. At the average of 85%, the student should pass the exam. This is our aim. Project leader, the guide, project champion, the head of the department, and the CTQ is pass percentage of the student. How do you measure this CTQ? It is the ratio of students passed to the improved teaching learning process, expected customer benefit, improved result, improved passing percentage, and decreased backlogs, and better scope for higher studies or job. The schedule, the start time, end time, etc. Plan. Students get admitted to the semester, classes are conducted, internal examinations are conducted, and semester end examination is conducted. Considering the internal and semester end examination, their result is declared where pass and fail is known, and thus pass percentage is being calculated. About the CTQ specification table, pass percentage of the students is known, that is calculated by total pass divided by total appeared in percentage multiplied by 100. The specification is it should be more than or equal to or more than 85%. What is the defect definition? If it is less than or equal to 85, it is a defect. A SIPOC, the total process we have done, as I said, students getting admitted to the class, classes running, CI exams, SW exams, etc. What is the input? Students, teaching aids, study material, teaching staff, and infrastructure. What is the output? Exam result is the output. What are the suppliers for the input? College and management. Who are the customers? Students, parents, industries, etc. Major. Here, this is the table where we have collected the data. Score of student in CI1, CI2, CIT 3. CI is nothing but continuous internal evaluation. If any assignment. Similarly, a CI4, if any student has missed CI 1, 2, 3 with a genuine reason and with the permission of the higher authority, can write for CI. And the last is semester end examination. It is based on the sampling. There we have written it is 100%, means every student has to be counted. With the data of the passing percentage that we have got, we do plot some of the graphical representations. These are obtained from the software called Minitab version 14. Now we are trying to calculate the Six Sigma level. Six Sigma level is calculated based on DPO, that is defects per opportunity, or defects per million opportunity. Once you have calculated DPMO, you have a standard chart where I can get the sigma level. If you see, we have got the DPMO to be 125,500. That is 1,25,500. For that, sigma level 2.6, 2.66, it is 1,23,000. Moving upon to the analyze phase, we conducted brainstorming to understand the causes, and here we got 76 reasons. The funniest part of brainstorming is you have to allow every criticism by the cross-functional team member. Having collected these 76 factors, now we categorize concern to teacher, concern to student, concern to classroom facility, related to material and equipment, similarly examination, and CIE and assignments. Now we draw the fishbone diagram, and from this we choose the top prioritized causes: class duration, CIE syllabus, CIE evaluation, subject syllabus, exam evaluation, and class strength. These are the 6 factors or causes considered from the brainstorming cause-effect diagram. Now, we have to have validation plan. How do you validate? For that, you are trying to have the solutions through timetable, teacher's report, scheme and solution, etc. If I go deep in one of the causes, like class duration, the validation method would be timetable. Already you have the timetable, example 8 to 9, the class for 80 days. Now I am going to measure whether the class is conducted exactly between 8 to 9. Now the CIE syllabus. If the first unit is to be considered for first CIE, now I'll have to depend upon the evidences or the report from the teacher. Thus, I'm going to have validation method for all the 6. With this, I'll move upon to improve stage, where I'm trying to generate the solutions. The validated causes, for the causes observed in the previous slide, is speed of teaching and coverage of syllabus. You have to analyze, you have to collect the data for that, and now you have to find the solution. Should I revise the lesson plan so that the speed will be controlled? Similarly, the syllabus, should I modify? Thus, I'll have to go for finding the solution for all the 6 causes. But when I find the solution, I'll have to keep in mind the potential risk. Because if somebody says, change the syllabus, yes, you can do it with some effort. If the question comes, change the teacher, are you in the position to do it? I have put a red star mark because lot of limitations you have while you are solving a project under Six Sigma. And in real situations of industry case studies, people fight between each other because you are in these situations. Now, implementation plan. The revised lesson plan, if you have planned for, it will be issued before the semester starts, both to the teacher and the student, and the responsibility of monitoring this is the head of the department. Similarly, review of internal assignment booklets would be by HOD and the teacher. Having my implementation plan with the responsibilities, now I'll measure the improvement. Having measured, I have got these 2 Sigma levels, before and after. I know the baseline. Before I make any modification, it was 2.66 sigma level. And after implementing the improvements, it is 3.07. I'd like to highlight here the SAA, semester end examination result. Whatever we have got, it was in terms of the grading. The range between 80 to 90 is A grade. Then we have taken the average of it, 85%. If you had able to get the data, the actual score of the student, that would really further take the sigma level from 3.07 to 3.07 plus. Well, with this, I'll move on to the last step. This is the control. Once you have reached an improvement, that has to be maintained. For that, we had a timetable in place, syllabus, lesson plan, which are standard and they are made to be followed. Format for recording time in and out of the class, feedback system to find students' follow-up of topics, format for monitoring topics covered, guidelines for question paper pattern, format for filling up internal and external marks, and students' attendance report. And these are samples for standard format for classroom, duration monitoring, serial number, date, timing, timeout, topic covered, and signature of the faculty. CIE and SW evaluation, serial number, USN number, CIE 1 marks, 2, 3, assignment, and total marks gained. You can also have another format, question number 1 for CIE 1, ABC bitwise. You can further go deep for question number 1 and each AI is ABC bit. You can go whether has it done the definition, sketching is attempted, formula is written, values are substituted. You can go deeper into the problem so that you'll get better solution. I think I have tried to put my best effort to tell you about the process of DMAIC with a case study, and I take this opportunity to thank Dr. S.S. Engineering, our beloved principal of Bessarabad Engineering College, Bagalkot, for having given me this opportunity. Equally, I thank Dr. Ambali Math, Technical Coordinator, Dr. C.M. Jabalgi and Dr. Mrs. Chaya Lakshmi, the coordinators of this FDP on Six Sigma. I thank Dr. K. Bhatt, Head of Electronics and Instrumentation Engineering Department, who have hosted this FDP. I lastly thank the participants for having patiently listening to this talk. Thank you one and all. Madam, please. Please. Okay. Okay. Kaizen is short-term goal project. It may be in terms of weeks, at most 1 or 1.5 months. Whereas Six Sigma, it would be between months to year. Some projects are there, like construction of dam, which have taken years together. So I think here, very clearly I say, this Six Sigma is long-term goal, where months and years are considered, and Kaizen is a short-term goal, where weeks or days are considered. Madam, in terms of, well, okay, I'll answer it. Okay, in my own way, I'll understand because I have not understood this question clearly. The limitations in terms of implementation, yes, there are a lot of implementations. Maybe the cost, maybe the time, etc. Limitation in terms of uh, the capability, yes. Some companies, they are well versed, they are well capable, they have the capacity to implement, whereas small and medium enterprises who are struggling hard to survive, they do not have this capacity to implement. Yes, in this way, they have some limitations. Madam. Thank you, ma'am.